Good afternoon. Friday we worked on changing equations that were in the form of slope-intercept form into standard form, and then we also worked on changing equations from standard form back into slope-intercept form. Both of the forms have their own advantage, and today what we're going to work on is focusing on that standard form equation. The standard form equation is really helpful when you're graphing equations based on their intercepts. So if you see right here, we have an x-intercept and we have a y-intercept, and you'll notice that on the x-intercept, my x-intercept is right here, and my ordered pair is -4, 0. And then when you look at the y-intercept, your ordered pair is 0, 6. So the first thing I want you to notice is anytime you are looking at the x-intercept, it's going to be some number, 0. And then when you're looking for the y-intercept, it's always going to be 0, some number. And those are for the ordered pairs. So that's what our focus is going to be on today, is finding those ordered pairs so that we can plot both of those points, just the x-intercept and the y-intercept, and then graph it super quick. All right, so the first thing we're going to do is focus in on our standard form equations. So this first equation is in standard form. Well, how do I know that my x-intercept is right here? The first thing that we know about that x-intercept, we could easily sit here and count and say, okay, that ordered pair is 5, 0. But what if I didn't have the graph? What if all I had here was my equation? Well, what do you know about the y value? The y value is 0. So if we're looking for our x-intercept, we know that y is equal to 0, so we can plug 0 in for y. So we have 6x minus 5, not times y, but times 0, and that's equal to 30. Well, we know anything times 0 is 0. So really, this ends up canceling out, and we're left with 6x equals 30, and then we can solve for x. We divide both sides by 6, and 30 divided by 6 gives us 5. So x equals 5. So what this tells us is the x value in the ordered pair here is 5. We can do the same thing for our y-axis, for our y-intercept. We could go ahead and count, and we know that the y value is 0, -6. But how could we determine that if all we have is the equation? Well, our x value on the y-intercept is always going to be 0. So we could find our y-intercept by substituting 0 in for x, and then solving the equation. Well, we know that 6 times 0 cancels out, so we have -5y equals 30. And then we can divide both sides by -5, and we get y equals -6. Now that doesn't mean that y is equal to -6. That means that the y value of our ordered pair is 6. We already know that the x value is 0. So let's go ahead and take a look at more of that. Our focus for today is to be able to calculate the x and the y-intercepts, not necessarily to graph it. Tomorrow we're going to work on graphing. So what I did here is just took some standard form equations, and we know that anytime we are looking for the x-intercept, our x-intercept is going to be something, 0. And when we look for the y-intercept, we know that that ordered pair is going to be 0, something. Well, we need to figure out what that something is. So let's start with the x-intercept. Our y value is 0, so we have 4x plus 6 times 0 equals 48. Well, 6 times 0 cancels out. We have 4x is equal to 48. Divide both sides by 4, and we get x equals 12. So our x-intercept is not 12, our x-intercept is 12, 0. So the actual intercept is the ordered pair, not just the number that we solved for. Then we'll go ahead and do the same thing for our y-intercept. We know that the x value is going to be 0, So we're going to plug 0 in for x. And then we have 6 times y equals 48. We know that cancels. We have 6y equals 48. We're going to divide both sides by 6, and the y value is equal to 8. So our ordered pair for the y-intercept is not 8. Our ordered pair is 0, 8. So we're looking for an actual ordered pair when we're finding our x and our y-intercepts. Now, in our homework last night, we had several problems that ended up with fractions. And in my last video on Friday when I was gone, we didn't talk about what do we do with those fractions. We just left it as it was. So today we're going to take it one step further, and we need to clear those fractions. In order to clear the fractions, you need to find the lowest common multiple of all three values, of A, of B, and of C. Well, we know that our A value is 1/3, our B value is 1 because there's no number there, and our C value is -3. So in order to clear this fraction, I only have one value that has a fraction, and it's 3, so we can just multiply everything by 3. So that 1/3 just turns into 1x. The 3 times 1y turns into 3y, and the -3, we're going to multiply 3 times -3 to get -9. Now I'm dealing with all whole numbers, which just makes it so much easier to solve for our x and our y-intercepts. So we'll go ahead and start by solving for our x-intercept, which means that it's going to be an x value of something, comma y. Our y value is 0. So we have x plus 3 times 0 equals -9. Well, that cancels out, and our x value is -9. So our first ordered pair is -9, 0. Now we need to go ahead and find our y-intercept. So to find our y-intercept, we know the x value is 0, and we need to find the y value of that ordered pair. So we're going to put 0 in for x, which leaves us with 0 plus 3y equals -9. We know that cancels. We're going to divide both sides by 3, and the y value of that ordered pair is -3. So our second ordered pair is 0, -3. All right, let's go ahead and have you try this one. I'll help you clear the fractions to start with. We only have one number that has a denominator, and that denominator is 3. So we're going to multiply everything by 3. So 3 times 2/3 leaves us with 2x. 3 times y leaves us with plus 3y. And 3 times -1 leaves us with -3. Now I'm going to go ahead, I want you to pause this right now, and I want you to solve for the x-intercept and the y-intercept on your own, and then when you're finished, hit play again so you can check your work. All right, so after you solved, you may have wondered, did I do this correctly for the x-intercept? Because you ended up with a fraction. Well, yes, you do end up with a fraction. We substituted 0 in for y when we're looking for our x-intercept, which leaves us with 2x equals -3. Divide both sides by 2, and the x-intercept, the ordered pair for the x value, is -3/2, but the actual intercept is -3/2, 0. And then we'll do the same thing with the y-intercept. We'll put 0 in for the x value, which ends up giving us 3y equals -3, and you solve that, you get -1. So our second ordered pair is 0, -1. All right, so next one, go ahead and solve this. Look for your x-intercept and your y-intercept, and then hit play once again. All right, so when we're looking for our x-intercept, we put 0 in for y, which ends up canceling out the y and leaves us with this. So you have -2x equals 6. Divide both sides by -2. You get x equals -3. So the actual intercept is -3, 0. And then when you're looking for the y-intercept, not much solving happening here. So you get y equals 6. But then remember, my ordered pair is 0, 6. So the y-intercept is 0, 6. Now the other piece of this is the graphing piece of it, which we will work on more tomorrow. But I want you to take a look at both of these graphs. You should be able to look at a graph and identify what the intercept is. So you might look at the y-intercept on this first equation and say, oh yeah, it crosses at y equals 3. But what is that actual intercept? If we're looking for an intercept, we're looking for an ordered pair. So that ordered pair is not just 3, the intercept is not just 3, it is 0, 3. And then for the x-intercept, what is that ordered pair? Well, if we look right here at where it crosses the x-axis, it's at 4, so the ordered pair is 4, 0. And then on the second one, again, it crosses the y-axis at 4, so our y-intercept is not 4, but it is 0, 4. And then our x-intercept, you can see that it crosses the x-axis at 5, so my ordered pair is 5, 0. All right, now I'm going to give you a little preview of what we're going to be doing in the next day. So tomorrow, we're going to have an equation, and if it's not in standard form, you need to put it in standard form, and then you need to solve for the intercepts. So to solve for the intercepts, just like we were doing, to solve for the x-intercept, we put 0 in for y, which means we're left with 7/2 x equals 5. And then if we solve 7/2 x equals 5, you end up, actually, you know what? I made a mistake. I am human, as you all know. So we're going to back this up and act like I haven't even started. The first thing that I need to do is I need to clear the fraction. So I need to clear this fraction. The only denominator we see is 2, so we're going to multiply everything by 2. That changes this to 7x. That changes this to plus 2y. And that changes the 5 to equaling 10. Now we have it in standard form with whole numbers, so now we can go ahead and start solving for our x-intercept and our y-intercept. So for our x-intercept, we're going to put 0 in for y, which leaves us with 7x equals 10. Because 2 times 0 is 0, that cancels out. Divide by 7, and we get the x equals 10 over 7, so 10 sevenths. So the ordered pair is 10 sevenths, 0. Now let's go ahead and find our y-intercept. We're going to put 0 in for x, which leaves us with 2y equals 10. Divide by 2, we get y equals 5. So the y-intercept is 0, 5. That one's much easier to plot. So we're going to start by putting a point at 0, 5. And then we also need to put a point at 10 sevenths. Some of you may wonder, well, what does 10 sevenths look like? I know that 10 sevenths is more than 1, and if you think about changing that to a fraction, it's a little bit more than 1.4, but less than 1.5. So you're going to actually kind of eyeball 1.4 or 10 sevenths, which is about right here. Now, once we have those two intercepts, yes, we want to make sure we label them. So you would label them with your ordered pairs that you already calculated. And then secondly, you're going to connect those with a line. So we're preparing ourselves to graph the equation by the intercepts. And if you can solve the intercepts like we did here, and then plot those two ordered pairs, then you can graph the equation by 2 points rather than making a t-table and plotting several points. So this is just another way to solve and graph equations. We call this graphing by intercepts. If you have any questions, please come in for Flex tomorrow. I promise you I will be back on Tuesday, and I can help answer any questions that you might have then.